All right, guys, I said I'd make a video of the first 7 problems on the Unit 5 review because we did run out of time last class in terms of finishing this review packet. And I did actually put all the diagrams on questions 1 through 7 on a separate page so I could show you my work, show you my approach, and show you how to solve these problems. So for the first question, they're asking us draw the 3 similar triangles represented in the diagram and then write the similarity. So they're talking about write the similarity statement. So we have for number 1, if you see we have the large triangle. Let me pull it over here. Then we'll have the medium-sized triangle. And I'll pull that underneath. And we'll have the small triangle. And I'll pull that down here. And you do want to mark on the triangles where the right angles are so you know where the angles go. So this goes here, and this goes here. And then you want to label each vertice in the triangle. So in small triangle, we have H, E, B. In the middle triangle, we have H, F, D. In the large triangle, we have F, E, and D. So one technique that I told you guys is to make up the other 2 angles in the large triangle to help you write the similarity statement. So each triangle already has 1 right angle, so you can make up any 2 numbers, but the idea is the 2 numbers want to be different. So let's say we say angle F is, let's say this is 30 degrees, and let's say this is 60 degrees. And then you want to find the triangles that share the common vertice and label those angles as well. So in the middle triangle, they both share angle F. So that means this angle will also be 30 degrees. Erase that. Erase that. And then in the large triangle, they share, the large triangle, the small triangle, they share angle E. So I'm going to make those angles 60, so they're the same. And now that you have 2 of the 3 angles in the middle and the small triangle, you can figure out what the angles are in the third one. So we should know that this angle will be 30, and we'll know that this angle will be 60. So now that we have all the angles labeled in all 3 triangles, now you can write the similarity statement. So you want to write ideally write the large triangle first, so it doesn't matter the order of the first one. So you can say we have triangle FDE. Now, we have to match that order in the small and middle triangles. So F is 30 degrees, D is 90 degrees, and E is 60 degrees. So we're going to follow this pattern when it comes to labeling the other 2 triangles. So we'll write our similarity statement, and then we're just going to play the matching game. So in the middle triangle, it's going to be F, H, B. I'm running a space. And then the small triangle, it will be angle D, angle H, and then angle E. So there's your similarity statement for the large triangle, the middle-sized triangle, and the small triangle. All right, the next problem. So this is number 2 on the unified review, and it's asking us to find the value of the variables in the given diagrams, and then simplify all radicals when necessary. So with this triangle, we're going to do the same thing. We're going to draw the large, the medium, and small triangle. So our large triangle is going to be this one. Our middle triangle is going to be this one. And our small triangle is going to be this one. Now, we don't have to label the vertices. So we don't have to label the vertices with letters like FEH or FDE, but you do want to indicate where the right angles are, and you do want to label the sides with what they give you in the problem. So we have a right angle here, a right angle here, and a right angle here. And then the small triangle, this is 8, and this is 12. And our medium-sized triangle, this is X, and this is 12. And the large triangle, this is going to be X plus 8. So when solving this problem, you want to ask yourself, which 2 triangles have a common side? So if you guys are looking, you should see that the middle-sized triangle and the small triangle, they both share a 12. 12 here and 12 here. So the idea is we're going to use those 2 numbers to be our geometric mean. So we're going to have 8 over 12 is going to equal 12 over x. We're using the numbers from the 2 triangles, and we're setting it up so that the numbers across are the same. That's going to be our geometric mean. So when we solve this problem, we're going to get 8x equals 144, and then I believe that is x equals 18. So let's try the next problem. We're going to do the same thing. We're going to draw all 3 triangles. So we're going to have the large triangle. I'll put it over here. I'm going to get the middle-sized triangle. I'll put that over here. And then I'll get the small triangle. And I'm going to put that over here. And I'll go ahead and write the angles in all of them, right angles. And then I'll label the sides. So in the middle-sized triangle, we have 15 and x. In the large triangle, we have 20. In the small triangle, we have 5 and x. I got the 5 because I subtracted those 2 numbers. So now if you look at all 3 triangles, do any of the 2 triangles share a common side? We're going to have an x here and an x here. So we're going to use those 2 triangles instead of the geometric mean. So we'll have 5 over x is going to equal x over 15. And after we cross multiply and solve for x, we get x squared equals 75. Then you do have to reduce that problem. So you can't leave it in x squared. You have to solve for x. So this is where they talk about having the simplifying the radical. So I'm going to take this over here. So x is going to equal the square root of 75. Now you need to find a perfect square that goes into 75. Or you need to find the highest perfect square that goes into 75. So x is going to equal the square root of 25 times the square root of 3. And we can reduce this down. So that's going to be your answer. X is going to equal 5 square root of 3. All right, let's continue on to the next problem. I wonder if I can drag this down. All right, so we have, this time we have two variables. We have x and we have y. But we're going to need the same thing. We're going to draw a large triangle. I'll drag it over here. I'll do my middle-sized triangle. Drag it over here. And then I'll draw my small triangle. And drag that over here. I'll get some space between. So I'm going to label the angles. Right angle, right angle, right angle. And I'll label all the sides. So in the small triangle, we have 6. We have x. In the middle-sized triangle, we have x, and we have 12. In our large triangle, we're going to have 18, which is the 12 plus the 6, and this is y. Let's see, am I missing any sides? Yes, I am. This is also y. So when we look at this problem, you want to solve for one variable at a time. So let's try to find out which two triangles have the same variable x in common. So if you notice, we have an x here and an x here. So we're going to be using this 6 and this 12 for a geometric mean. So we're going to have 12 over x equals x over 6. And we can go ahead and solve that. So we get x squared equals 72. X equals the square root of 72. X equals the square root of 36 times the square root of 2. X equals 6, square root of 2. So that's your final answer. Now we need some more space for solving the variable y. So if you look at the two triangles, you notice there's a y here and a y here. So we're going to be using the large triangle and the middle-sized triangle. Now be careful on this problem. So I said be careful on finding the value of y because in this triangle, in the middle-sized one, we have two legs. We have an x and we have a 12. Now the question is, in the large triangle, we have a leg, we have y, and we have the hypotenuse. Now the question is, which numbers are you going to use in the geometric mean? Now this is where it is helpful to use the idea that we used back in the previous problem, the number 1, where we put angle measurements in all the triangles to help us identify which one goes first. So we're going to try this technique, so pay attention. So if we look at our large triangle and we label the sides, let's say this is 30 degrees and let's say this is 60 degrees. Now, the large triangle and the middle-sized triangle, they're going to share those two angles. So that means I'm going to label this angle 30 degrees, and now that I know this angle, this is going to have to be 60 degrees. So now that I have the angle measurements, now I can write a geometric mean based on where they go. So I may have showed you guys this box with the table format, but we are using the middle-sized triangle and the large triangle. It's going to be a bad box. And then since we're solving for the variable y, you want to look at the middle-sized triangle, large-sized triangle, and ask yourself, those sides are opposite what angle? So in the middle-sized triangle, the y is opposite the 90-degree angle. So I'm going to put a 90 right here. In the large triangle, the y is opposite the 60-degree angle. So I'm going to put 60 degrees right here. Now, if you fill in the chart, you should come up with a geometric mean you should be able to solve for the variable. So you want to ask yourself now, in the middle-sized triangle, what is the side that is opposite the 60-degree angle? And that's going to be our 12. So we use 12 instead of x. In our middle-sized triangle, what's the side that's opposite the 90-degree angle? That's our y. If we look at the large triangle, what is the side that is opposite the 60-degree angle? That's our y. And in the large triangle, what is the side that is opposite the 90-degree angle? That's your 18. So now we can convert this. So 12 over y equals y over 18. So now we can solve that just like the geometric mean. So we get y squared equals 216. And that is, I don't think that's a perfect square. Let's get some more space. So we need to find the highest perfect square that is a multiple of 216. And we get y is the square root of 36 times the square root of 6. So this becomes y equals 6 square root of 6. And that is our final answer. So this problem was a little bit longer because we had two variables, but your technique should be the same for any right triangle with an altitude that creates three similar right triangles. So we have one more page to do with, I think, 3 more problems. So this one, we have two variables again. So let me draw the large triangle. Let me draw this one looks like the middle-sized triangle. Oops. I'll put that here. And the last one, we'll call it the small triangle. I'll put that down here. So in the last problem, since we had two variables, we had to label the angles so we knew which side to use. So let's do the same thing first. So I'm going to put my right angle here, my right angle here, and my right angle here. And then let's say this is 30 degrees. Let's say this is 60. Now our middle triangle is going to share this angle with the large one, and then our small triangle will share this 60 with the large one. So that's where we get that. And then once you get the other two angles, you know that this is 30 and this is 60. Let me erase those lines. And then next we'll indicate the side. So in the large triangle, this is 14. In the middle triangle, this is 8. And our small triangle, this is 6. So I did 14 minus 8 equals 6 to get that. And then in our middle triangle, this is y. In our small triangle, this is y. In our large triangle, this is x. So let's use the middle triangle and the small triangle to solve for the variable y. So we'll have 8 over y is going to equal y over 6. So we get a y squared equals 48. Y is going to equal the square root of 48. And we can divide that. We can simplify that. Erase this. So then I'm going to go, let's take it down here. So y equals the square root of 16 times the square root of 3. So y is going to equal 4 square root of 3. All right, now I've got to find the variable y. I mean variable x. So let's do, if we're using our variable x, we can do so I forgot to label one of the sides. So this is x. So now that we have two triangles with the variable x, now we've got to determine which side to use. So you need to ask yourself, okay, in the large triangle and in the small triangle, the x is opposite what side? So here's our large, here's our small. So let's make our little chart. So we're using our large triangle and our small triangle. And then in our small triangle, the x is opposite to 90 degrees. And in our large triangle, the x is opposite to 30 degrees. So now we just fill it in. In our small triangle, let's do that first so we can see it. So the side that's opposite to 30 is our 6. In the small triangle, the side that's opposite to 90 is our x. In the large triangle, the x is opposite to 30. And the 14 is opposite to 90. So then we can set this up in our geometric mean. X over 14 equals 6 over x. We'll cross multiply, get x squared equals 84. So x will equal the square root of 84. And we simplify that. So what's the highest perfect square that goes in 84? And actually, I think it's going to be the square root of 4 times the square root of 21. And there's our answer. X is the square root of, or x is 2 square root of 21. And there's our other answer. So there's your x and there's your y. All right, the last problem. What's the last problem? Nope, we got two more problems. So let me erase a little bit so we can see. All right. So let me make my large triangle. Let me make the middle-sized triangle. And I'll make the small triangle. I'll do my right angles. And then I'm going to go ahead and create two angles so I can find the corresponding sides. So I'll make this 30, I'll make this 60. These two are the same. So this is 30. Those two are the same. This is 60. So this becomes 30 and this becomes 60. And then let me go ahead and label the lengths of the sides. So we're going to have z plus 2, x, y, z, 4, and y, 2, x, and 4. So these are three variables. This problem becomes definitely a longer, more complicated problem. So let's look at, there's a lot of variables, but let's look at, hopefully you guys have noticed a pattern, but if you look at the middle triangle and the small triangle first, they normally share a common side. So let's use that to find the geometric mean between those two sides. So we're going to use 4 and 4. Now the idea is you want to use as many numbers as you can, because if you have two variables in your geometric mean, you won't be able to solve it. Like for example, if we had, I don't know, z over y equals y over z plus 2, we couldn't solve that because we don't have enough numbers. So the idea is you want to set it up so you have enough numbers so you can solve for each variable. And if we use the 4 and the 4, that's going to help us. So the idea is if we can use this 2 first, which is opposite the 30-degree angle, we want to use the corresponding side in the middle and the middle-sized triangle. So we're going to have our middle-sized triangle, our small-sized triangle. I might not even do this, but I'll do it anyway. So the 4 is opposite our 60-degree angle, and the 4 is opposite the 30-degree angle. So we're going to be using those sides. So we're going to have in the middle triangle, we'll have z and 4. And the small triangle will have 4 and 2. So that's an easy geometric mean. Z over 4 equals 4 over 2. So 2z equals 16. z equals 8. So actually, let's use this and plug it into any parts of the other triangles where they give you a value of z to make our life a lot easier. So that means we can go back and change. In this large triangle, we can change this to, can't even see it. We can change this to 10. We can change this one to 8. Oops. This one to 8. Messed it up. So now the problem gets a little bit easier. So I'm going to give it some more space. Let me erase this. Let me erase this. All right, so we found our variable z. Now let's find another variable. Let's find the variable x. Right? So x is in the small triangle and the large triangle. So we'll do our small triangle, our large triangle. The line down the middle, the line down the middle. And x is opposite the 90-degree angle. And x is opposite the 30-degree angle. So in our small triangle, the side that's opposite our 30 is 2. In our small triangle, the side opposite the 90 is our x. In the large triangle, the side opposite 30 is our x. In the large triangle, the side opposite our 90 is 10. That we can solve. So we get x squared equals 20. And that becomes x equals the square root of 20. X equals the square root of 4 times the square root of 5. X equals 2 square root of 5. So there's your solution for x. And then let's go back and change that in the problem so we make our life a lot easier. 2 square root of 5. X. So I'll put a 2 square root of 5 and a 2 square root of 5. Now the only variable we have left is y. And y is in the large triangle and the middle-sized triangle. So let's make some more space. So we'll have our large triangle, our middle-sized triangle. And our y is opposite the 90-degree angle, and y is opposite our 60-degree angle. So in our large triangle, we'll have y and 10. In the middle-sized triangle, we'll have 8 and y. So we'll get a y squared equals 8. Y equals the square root of 80. Y is going to equal square root of 16 times the square root of 5. So that becomes y equals 4 square root of 5. All right, so those are all three variables in that question, x, y, and z. And that problem did take us a lot of time, but that's, to me, that's the simplest way to do it. If you have a better way, you can use it. But just make sure you show me your work. All right, going to the last problem in the review. So hopefully this will take me less than 5 minutes and be done at 40 minutes. So we're going to have Expand. We'll have a large triangle. We'll have our middle-sized triangle. And we'll have our small triangle. And then let me label the angles. We'll have a right angle here, a right angle here, and a right angle here. And then this is Y. This is 4. This is 6. This is Y. This is Z. This is X. This is Z. This is 2. And this is X. All right. So same approach. Let's label some angles. I'll use different angle measurements this time. So let's use, this might be 20. And let's say this is 70. So these two angles are the same. So this is 20. And these two angles are the same. So that's 70. That becomes 20. That becomes 70. 70. Okay. This a little bit more. Close enough. All right, so now let's solve for some variables. So let's see. The idea is, let's look at the triangle again. Let's see, is there anything that we can solve that looks easy to solve? So normally the idea is, if you find this middle side that the middle one and the small one share, they will share that in common. And in the middle triangle and the small one, let's see. So the X is opposite the 20 degrees in the middle, and it's opposite the 70 degrees in the small. So yeah, we can do that one. So we'll do $20, $70, middle, small. X, this is 4, and the small we have 2 and X. So we get X squared equals 8, and X equals the square root of 8. So there's our X value. X is 2 square root of 2. So let's go back in the diagram and change those. X is 2 square root of 2. X is 2 square root of 2. All right, now let's solve for another variable. Let me erase Give us some space. Let's solve for y. So y is going to be in the large and middle-sized triangle. Middle, large, and the y is opposite the 70 degrees in the large, and the y is opposite to 90 degrees in the middle. All right, so we're going to have, in the middle-sized triangle, we have 4 and y. In the large triangle, we have y and 6. So then we get y squared equals 24. Y is the square root of 24. So this is the square root of 4 times the square root of 6. Y equals 2 square root of 6. So let's go in the problem and fill that in the diagram to make our life easier. So 2 square root of 6 where y is. I cannot see that. And here. All right, the last variable, z. All right, the last variable z is in the small triangle and the large triangle. So the small triangle, the large triangle, z is opposite the 20-degree angle and opposite the 90-degree. And let's see, in the small triangle, we have 2 and the z. In the large triangle, we have a z and a 6. So we get z squared equals 12. Z equals the square root of 12. Z equals the square root of 4 times the square root of 3. Z equals 2 square root of 3. All right, so that's how you solve problems with right triangles that have an altitude that create 3 similar triangles. And the 1 to 3 variables get kind of long, but if you guys follow the same steps, you can't go wrong. If you do have another way that's easier, like I said, you're welcome to use it, but just make sure you show me your work. And don't forget that the answer key for the Unit 5 test review is on Blackboard. So check your answers and make sure you bring that in tomorrow in the class, because the test is a little difficult. But you do fine if you study.